Hi guys, in this video I'm going to show you how to use simulation module of SolidWorks. What we are going to do is perform static linear analysis on a cantilever beam as shown in this picture here. We will make this beam, cantilever beam, we will fix one end of the beam and then we will apply forces on the top surface of the beam and we'll analyze how this beam will perform under the different loading conditions. To do that in SolidWorks, we have to use a simulation module that will actually virtually perform this testing. Another name for this is finite element analysis. This is a vast field where we can uh, break any complex mechanical part or mechanical product. If we want to perform stress strain analysis on that part, we want to perform the factor of safety analysis on the part to see whether the part is safe for the type of work that the part is supposed to be used in. To do that analysis without spending a significant amount of resources on actually manufacturing it or testing it physically, it's much easier, much cost effective to test it on a computer in a simulation environment, and based on that then you can optimize the design parameters and they before you can finalize the design. So let's do that. I'm not going to this video is not about discussing the whole field of finite element analysis. You can learn that on your own, but I'm just going to give a quick overview of how to perform uh, a simple finite element analysis study using a simulation module of SolidWorks. A very quick overview. Okay, so let's start. I want to start with a new part file. Okay, the dimensions for this part are in millimeters. So I'm going to change at the bottom here. This is right now set up in IPS, which is inch pound second. So I'm going to change that. Click there, and I'm going to change it to mmgs, millimeter gram second. Okay, so that's what I do first thing. Then let's make the part. So I'm gonna select right plane. Okay, and then go to the features tab. So right plane features tab, we want to extrude the sketch that we are going to make on right plane. So extruded boss, that will automatically take you to sketch mode, and now you can draw a rectangle. Center rectangle is fine. Center I will put on the origin. The dimensions of this rectangle are smart dimension 45 millimeter is the height, and the width is 25 millimeters. Okay, 45 by 25. Sketch is complete, fully defined, completely black. So exit the sketch, and now you can define the length of this cantilever beam, which is 500 millimeters. Okay, so there we have it. I'm gonna click OK. So our part is ready. Now we are, of course, to perform any mechanical analysis, stress analysis, we need to know what material this part is made up of, because a lot depends on the choice of material, right? So right now we haven't applied any material to this part, so let's go ahead and apply plain carbon steel as the material, right? So here, material not specified, right click on that and edit material, and we want to choose plain carbon steel. So right here under the steel alloys, you can choose plain carbon steel. So all the mechanical properties of plain carbon steel will be applicable to this beam, cantilever beam. So apply and close. Okay. Uh, Another thing we can do before we go any further is save this part. So I'm going to save it, save as, We'll put it in the temporary files here. Part 3 is whatever name you want to give, is fine. Save. Okay, we are all good now to start the simulation, right? So first thing, we will have to add in the simulation module. To do that, let's go to tools, scroll down and until you see add-ins. So click on that, and SolidWorks simulation is what you should checkbox, right? SolidWorks simulation, and okay. So that's good. That will add a new tab. Let's see, a simulation tab here. Simulation tab is what we are interested in. Okay, so with that, now let's start the study. So here, under the study, we can click on that small arrow to start a new study. So let's click on new study. Okay, the name of this new study is static 1. Looks good. You can explore other options, but it's so far so good, so I'm going to click OK. And that will create some nodes here that you will have to use. First, what we want to do is we want to create a mesh. A meshing is a process of breaking this part down into some small tiny elements, which are necessary for finite element analysis. So let's do that. Create mesh. So there is a mesh option here. You right click on mesh and click on create mesh. Okay, now you have some control how fine you want to create your mesh, or how tiny elements you want to divide this part in, or you want to go cohere. So there's some things you can do. There's a lot to learn about each one of them. For example, if you go advanced, but for this, the purpose of this tutorial, we're going to just use the default options, right? So whatever SolidWorks has chosen for us, looking good, we can click OK. And now you can see how the part is divided in these small elements, right? They're connected to each other at nodes. Uh, so that's the first step, number one. Create the mesh. Okay. Step number two is apply boundary conditions. So for that, like for example, one end of this beam we want to fix it, right? So that will be our boundary condition. So we have option called fixtures here. So we right click on fixtures, and we can use fixed geometry option. Fixed geometry, and we want to fix this end. Okay, so I'm gonna select this end, and let's click OK. So now that end of the beam is fixed. If we wouldn't have fixed that end of the beam is basically floating in the space, right? So if we apply forces to the beam, because it is freely floating in the space, it will just keep flowing, right? It will not deform, or we won't be able to perform uh, the stress analysis. So now that we have fixed this beam at one end, I'm put it back in isometric orientation. Okay, so we did that. Next thing we want to do is we want to apply loading. So far, what just to summarize, we created the part first, then we applied the material to the part, then we started a new simulation study on the simulation tab, and within the simulation study, the first step is to create mesh. So that's what we did. Second step, to add fixture or fixed, decide which side is fixed or which surfaces are fixed. So we fixed that end of the beam. Step number 3 is to apply forces. Okay, and then we can run the simulation. So let's apply some external loads. That is under this option called external loads here. So right click on that, and you can see there are different types of loading conditions you can apply, but I'm going to keep it simple. As I said, choose force. Okay, and systems international unit system. There are different unit systems are there, English, metric. I'm going to keep it SI, and use 5000 Newton. 5000 Newton. Okay, and then we can click, uh, we can, of course, we have to select the surface on which you want to apply the load. So I want to apply the load on this surface, and you can see, already see preview of the force that you are applying on that face. Everything looks good, so I'm going to click OK. Now we have to run the simulation and see how the beam will perform under this loading condition. So let me right click on static one here, and there is an option called run. So let's run it. It takes some time, and you can already see uh, there is a scale that is given here. This diagram here is called one Mises stress diagram, or you can see here results. On the left hand side you will see results, and we have uh, different results that are showing up here, right? So one Mises stress, and the scale is here. So and there is some color coding. That means highest stress is uh, in this red color, shows the highest stress, which is 1.543 multiplied by 10 to the power 08 Newton per meter square in this area here, right? And blue is the basically the lowest stress, one Mises stress. The yield strength of this part is 2.2 06 times 10 to the power 08. So highest loading that we have on the beam is less, the highest value of the one Mises stress is less than the yield strength of this part. So that means as long as we stay below yield strength, the part is safe, right? So that is that. Now there are some other things you can see. For example, displacement, right? Displacement, double click on that and you will get the displacement. Again, same idea, we have a scale, color coding, you can study that. Strain diagram is also there, right? Now I'm going to right click on results, and there, uh, define factor of safety plot, because if, this idea of one Mises trace or displacement, strain, engineers know all of that, but for common people, uh, they haven't studied this strength of material and those type of courses, so they wouldn't know, they wouldn't understand this language. So for them, the best thing is the factor of safety. If the factor of safety is above 1, the part is safe. If factor of safety is below 1, the part is not safe. Now 1 is the bare minimum, right? But if some parts are very critical parts, important parts, maybe used in aeroplanes, and where if the part breaks, the consequences can be disastrous. So we cannot just rely on factor of safety of 1. Then we have to increase factor of safety to for a safe operation, right? So it is a balancing act between how strong the part we want to make and how much money we want to spend, because the stronger the part you make, the more resources it's going to need, more material it's going to need, and it's going to be expensive. So we can define a factor of safety plot here, and uh, so that will create a factor of safety plot. It says step, we can say all okay, and as you can see, factor of safety plot, uh, right now we are on, and you will see here the factor of safety minimum factor of safety of this part here is 1.4. So is higher than 1, which is a good news, right? Factor of safety scale is also given where the part is the safest would be the blue areas or the green areas. You can see this one here. This area is, you can see, where the higher factor of safety is high on this area. But 1.4, you can see here also 1.43, which is same as here 1.4. So that's the so it's quite a safe part, right? Now mm, if you want to keep a minimum factor of safety too, then you have to, of course, optimize the parameters further. But as of now, without any context of what kind of application this cantilever beam will be applied, will be used in, I believe factor of safety of one should be okay for now. So that's how you can perform simulation or stress analysis on mechanical parts. So this is as I said, a very quick uh, and shallow review of simulation. There is a lot to learn in this. You can explore on your own. But for now, I will stop the video. Thank you.